Okay, so the purpose of this video is to explain lesson 9.2 about graphing inverse variation. Okay, so inverse variation has two parts. Okay, inverse variation is anything in this form, y equals k over x. So you'll see that here, parent function. Later we're going to do some translations, but for right now let's just talk about this graph. F of x is y equals 1 over x, and that's what we see here in red. So what inverse transformation looks like, inverse variation, sorry, is you have these two separate parts of the graph, and they're actually called branches. That's the vocabulary term for them. There's two branches. And let's look at y. Okay, so let's make a little table of values. When x is 0, what happens to this graph? It explodes. Okay, so you have f of x is equal to 1 over 0 and algebra explodes. So x can't be 0. So that's why there is no value here. That's actually a vertical asymptote. The line x equals 0 is a vertical asymptote. It's a value that this function cannot be. Okay, so let's do something on either side of that. When x is 1, okay, so instead of k, let me go ahead and write in the value 1. So when x is 1, we have y equals 1 over 1, which is 1. When x is negative 1, we also have negative 1. That's an explosion. Okay, so you know that can't happen. So when x is 1, y is 1. Let me actually turn on my grid here. Give me just one moment. Okay, so when x is 1, y is 1. You see this point here. When x is 2, let's go over a little bit farther. When x is 2, y is 1/2. So 2 1/2. When x is 3, y is 1/3. When x is 4, it's 1/4. So you can see these values descending, and they keep getting closer and closer to 0, but they'll never get there. There's no value for x I could plug in that would make this 0. Then when x gets smaller, let's do some different values of x. Let's talk about x whenever it's a fraction. Okay, so let's say when x is 1/2, well, what is y? Well, if you come over here and you plug in 1/2 for x, you get 1 over 1/2, which is not equal to 1, it's equal to 2. 1 divided by 1/2 is 2. When x is 1/3, y is 3. When it's 1/4, y is 4. So when you're at 1/2, you're up here at 2. When you're at 1/3, you're up here at 3. When you're at 1/4, you're up here at 4. And so you see how it keeps growing and growing and growing, but again, x can't be 0, so you can't plug in the value 0 to see what it would be for y, because it's not defined. But then when you go farther this way, when you go to the negative x's, you see the exact opposite of what we saw on the other side. That's why you see this reflection over here. Okay, so when x is negative 1, y is negative 1. We already talked about that point. When x is negative 2, y is negative 1/2. When it's negative 3, we have negative 1/3. So you see how it keeps getting smaller and smaller and smaller. And then similarly, when x is negative 1/2, y is negative 2, negative 3, negative 4. So you see that's how this graph shows up. Okay, let's do example 1 from your book. Example 1 says draw the graph y equals 6 over x. So to do that, let's create a table. Let's do x and y values, and let's do a lot of them. Okay, so first of all, x can't be 0, but in the middle, let's just plug in 1. When x is 1, what is y? Okay, if you plugged in 1 for x, you would get 6 over 1. So if you plug in 1 for x, you will get 6 for y. If you plug in 2 for x, you will get 6 over 2, which is 3. If you plug in 2 for x, you will get 3 for y. If you plug in 3 for x, you get 6 over 3, and that gives you 2 for y. If you plug in, let's go ahead and just skip all the way to 6. If you plug in 6 for x, you get 1 for y. Okay, let's go ahead all the way over here to 12. You plug in 12 for x, you got 6 over 12, which is 1/2. You get 1/2 for y. So about here, something like that. Okay, now small value. If you plugged in 1/2 for x, you would have y equals 6 over 1/2, which is equal to 12. So 1/2 is way off the screen. So those points will connect, and that will make this side of your graph. The other side is the reflection of this. Okay, so when x is 2, y is 3. When x is -2, y is -3. When x is -1, y is -6, which is here. When x is -3, we're at -2. -6, we're at -1. So this is what our graph would look like. Okay, so I didn't fill in the rest of those table values, but so when I plug this in, we're going to go through all these points. -1 for x gives you -6. So we're graphing y equals 6 over x. So I'm going to change k to 6, and there you see we have it. Okay. Our asymptote is the same thing. We have two asymptotes. Okay, so I've only talked about one of them. One of them is the line x equals 0. This is an asymptote. But also there's the line y equals 0. Okay, y can't ever be 0 either. And the reason why is there's no value I could plug in for x that would give me 0 for y. And so y is also an asymptote. So we have two asymptotes, a vertical and a horizontal asymptote now. Okay. Check your understanding 1 says draw this graph, y equals 16 over x. Okay, very similar. Let's plug in some values. When x equals 1, y is 16. When x equals 2, y is 8. When x equals 4, y is 4. So that's the first one I can see. When x is 8, y is 2. And so I'm going to go through both of these points. When x is 1, y is 16, 2, it's 8. So just off the screen right here, I'll just draw it really big. And you can see it. And the reflection, when x is 4, y is 4. When x is -4, y is -4. When x is -8, y is -2. When x is -2, y is -8. So we're going to go through those points. That's what the graph is going to look like. So let's come change this to 16. And there you have it. Alright, so that's how it works for graphing with just a k value. What happens when you compare two graphs? Let's just compare two graphs. Let's compare the graphs y equals 4 over x and y equals 9 over x. This is example 2. So how does the k value, which is what this is, the k value is 4 here and the k value is 9 there. How does the k value affect the shape of the graph? That's essentially what this is asking. Well, let's do this dynamically. Okay, so let's go down here. When k is 4, this is what the graph looks like. When k is 9, let's go over to 9, let's plug in 9. This is what the graph looks like. So how are they different? The k value determines how close or far away you are from the origin. Okay, so if k was 0, you would have this. Let's plug in 0. You'd have f of x equals 0 over x, which is equal to 0. So if k is 0, you have the line f of x equals 0. That's what the red line is. Then when k becomes a negative number, it just flips. So instead of being in the first and the third quadrant, you are in the second and the fourth quadrant of the graph. And everything else behaves the same. The bigger the k value, the farther from the origin you are. The smaller the k value, when you're at 0.1, you're very close to the origin. You're not quite there, but you're very close. Alright, so the difference between these two graphs is y equals 9 over x is much farther from the origin than y equals 4 over x. Okay, so check your understanding. 2 says use a graphing calculator to compare y equals 25 over x and y equals 100 over x. Okay, these are going to look identical. It's just this graph is going to be farther from the origin. I can't even show it to you on this scale. I would have to zoom out quite a bit to even put that on there. Okay, and actually my k value doesn't even go high enough. Okay, I've only got it set to go to 20. But you can imagine it's going to do the same thing. Okay, it's farther away. Alright, example 3. Compare the graphs of y equals 1 over x and y equals negative 1 over x. So if your k value is 1 versus negative 1. Okay, let's zoom back in to get a better picture. And then let's plug in 1 here. That's y equals 1 over x. Change it to negative 1. And it just flips. They're the identical graph. They're just in the opposite quadrants. Instead of being in quadrants 1 and 3, they're in quadrants 2 and 4. Asymptotes are the same, x equals 0, y equals 0. So that's the only difference. Okay, example number 5 talks about translating. So now we're going to talk about this form, standard form over here, where you have this x minus b and plus c. So let's go ahead and add in 1 for both of these values so that you can see what just happens. Alright, so that looks kind of crazy. But let's talk about what's going on. So all that happened is when b was 0, let's go ahead and put them both back to 0, or put this back to 0. Okay, so when b is 0, what we're going to have, there we go, as you have the line negative 1 over x. Okay, and as the b value changes, the graph just shifts. So as the b value gets bigger, the graph shifts to the right, and as the b value gets smaller, the graph shifts to the left. Okay, also notice how the equation is changing. If b is 4, let's change k to positive 1, just so that it's easier to look at. Okay, if b is 4, we have the same graph as f of x, which is now showing in black, and the red graph, 1 over x minus 4. The way that these two are different is g of x is shifted 4 to the right. If I shift it back 4, then we have the same equation, same graph. If I shift b to the left, okay, now we have positive number under here because the standard form is x minus b. So if b is negative 6.1, then you would have x minus negative 6.1, which shows up as x plus 6.1, and that's how it shows up underneath here. So this is really similar to all the other translations we've done. The b value, the value that goes with x, shifts the graph horizontally to the right or the left, and the c value, the value that goes with y, shifts the graph vertically. So I'll change this back to 0. Okay, so all this does is it shifts the graph vertically. Moves it up or down. Okay, now down here you'll notice asymptotes. The asymptote for the graph changes whenever you translate it. So the horizontal asymptote is always y equals c, this c value out here. So I'll write that down. The horizontal asymptote is always y equals c. The vertical asymptote is y equals b. X equals b. Sorry, x equals b. So these two asymptotes, this one showing in green, and then the horizontal showing in purple. The x equals 1, that's your b value. Y equals negative 4.5 is your c value. So that's how the translations work. Pretty much the same as everything else. The k value changes the parent function also. So the parent function is here, f of x equals k over x, and then these shift also. Alright, let's set these back to 0, and then let's do a problem from your book. Okay, so example 5 in your book says, sketch the graph of y equals 1 over x minus 2 minus 3. Okay, so a good way to do these problems is to think about what would my parent function look like. Okay, the parent function for this graph is y equals 1 over x. It's just the k value, which is here, over x. And we already know what that one looks like. You could make a table of values and graph it, but this is what it looks like right here. And now you have this x minus 2 and this minus 3. So let's go look at standard form. Our b value is x minus b. Okay, and so right now b value is equal to 2. Our c value, we should have plus c, and we have minus 3 out here, so that's like saying plus minus 3. Our c value is negative 3. So, if you look at these two equations, what that means is we're now going to have a vertical asymptote at x equals b, which is 2 in this case, and we'll have a horizontal asymptote at y equals negative 3. So here are our two asymptotes. At x equals 2, let me use my line tool. Asymptote at x equals 2. Okay, there is my vertical asymptote. And my horizontal asymptote at y equals negative 3. That's somewhere right in the middle of this, guys. Alright, so what's going to happen is I'm going to have this exact same graph that I had. Oh no, got to shift them over. Can I shift you? Thank you. There we go. Alright, so I have the exact same graph that I had before, but now it's shifted over here as if this was the origin. Okay, so it's always a good idea to draw your asymptotes first and then kind of treat that like that's the origin. Okay, over here, if I plug in a value here, let me zoom in a little bit. Let's see if I can zoom in a little bit. Oh, that's going to mess it up. Never mind. Undo. There we go. Oh no, undo again. Okay, so let's just look at this and let's plug in some values. Okay. Why is I undid too much? Alright, so if x was 2, y would be 1/2. So if I treated this like the origin and I went over 2, then y would be 1/2, which is like here. If x was 1/2, then y would be 2, so that's about here. And so our graph is going to go through these and it's going to approach, and then the other side does a similar thing. Let me clear all this stuff off and actually plug in the values. Okay, I'm going to delete these also because the asymptotes are going to show up. Alright, so k was 1, b was 2, c was negative 3. Alright, so this was the equation that we were asked to sketch. You can see the asymptotes, y equals c, x equals b, and here they are on the graph. And then if this was the origin, this red is the exact same as this blue graph is against the real origin. So it's just shifted over to the right 2 and then down 3 every point on the graph, including the origin. Alright, so that's how you sketch those graphs. Let's do one more example. Find the asymptotes of y equals negative 1 over x plus 7 minus 3. So the first thing we want to identify is what is the parent function here. The parent function is f of x equals k over x, which in this case is negative 1 over x. That is my parent function. So let me plug these values back in as 0. And k is now negative 1. What's going to happen to this graph when I hit enter? It's going to look the exact same, but it's going to switch into the second and fourth quadrants. Okay, so now we have our parent function. Our b value is negative 7. Okay, so we have x minus b, and then that ends up being x plus 7 in our case. So what is b? Well, get rid of the x's, and you have negative b equals 7, so b is negative 7. That's one way that you can do it. Alright, so b is negative 7 in this case, which means x equals b is our asymptote. So x equals negative 7 is one of our asymptotes. And that's going to shift the graph, everything on the graph, to the left 7. So let's plug in negative 7, shifts the whole graph to the left 7, and our asymptote x equals -7 is showing up. Okay, our c value is -3 again, so it's going to shift the entire graph down, and y equals -3 is our horizontal asymptote. So here are two asymptotes, y equals -3 in purple, and x equals -7 in green. You can see that there. And then the rest of the graph stays the same, it's just shifted. So the way that you graph this is you need to figure out these two asymptotes, put them on here, then treat this as the new origin, the place where the two asymptotes meet, and just graph the parent function from there as though that was the origin. So you plug in a value for x, like 1, you get -1. So from here you go 1 and 1. And you would graph that, +1 for x, -1 for y, and you graph that. You plug in 2 for x, y equals -1/2 is -1/2. So you go 2 over, which is 1, 2, and you go down to -1/2. Uh-oh. Phone's ringing. Sorry about that. And you graph these points. And you keep picking points on the graph, and you keep graphing them until you get what you want. But you don't have to, after you shift those asymptotes, you don't have to worry about these two parts. All you're doing is graphing this, but treat the asymptote as the origin. That's the way that it shifts. Okay, example 6. Writing the equation of a translation. Uh-oh. I thought I switched to my mouse tool and I didn't. Alright, let's put this back at 1. Makes it look prettier. Okay, so example 6 says write the equation for the translation of y equals 5/x that has asymptotes at x equals -2 and y equals 3. So that's telling us our b value is -2 and our c value is 3. So if our b value is -2, then I would plug this in. Y equals k. What is k? K is the value that's here, so 5 over x minus b plus c. Okay, b is -2, so I plug that in. X minus -2 is x plus 2, so we're going to have the graph x plus 2 and then plus c. This is the equation of the graph that has asymptotes at -2 and +3. Let's plug in those values and we'll see that again. If the b value is -2 and the c value is 3, those are our asymptotes, -2 and 3, and this is the equation of our graph. It's, k value is 5. There we go. So it's this black line, the black graph, shifted. So pick a point on the black graph right here. I'll just say this point. Or actually, let's find something that goes through. Let's go here. It is shifted 2 to the left, 1, 2, 1, how do I do this? Oh, okay, that's -2. So 2 to the left and down, and up 3. So about here. So this point is shifted to here on the graph. And you can look at the origin, that makes it easier. It shifted 2 to the left and up 3. And that's the place where both graphs meet. Alright, check your understanding. 6 is where we're at now. 0. Let's plug this back at 1. Check your understanding. 6 says write an equation for the translation of y equals -1/x that is 4 units left and 5 units up. So we have this as our parent function. K is -1. And then it shifted 4 units left and 5 units up. So if it shifted 4 units left, our b value is 4, but then it's left, it shifted left, so our b value is -4. And our c value is, it shifted 5 units, and it shifted up, so our c value is a +5. So we plug that back into this equation. So g of x is equal to k, which is -1, over x minus b plus c. Again, x minus -4 gives you an x plus 4. So g of x is going to look like this. -1 over x plus 4 plus 5. Let's go ahead and plug those values in. It shifted 4 to the left and up 5. So here are our asymptotes, y equals 5, x equals -4, and this is what our equation looks like. The end.